Okay, so this is chromatography CH. This is the course code for this. It's CH, okay, 440. This is advanced analytical chemist, and we'll be able to break one or two things there inside. All right, so that is it. Okay, so when you talk about chromatograph, one, we can define chromatograph as all right. Let me just change the pen. So we can define chromatograph as the physical method of separating of substance in a mixture or complex substance. So this is just a physical, so you can define it in as much as you want. It has a lot of definitions. So this is just the physical separation, all right? It's involving physical. Okay. So physical separation of chemical or just of substance in a mixture. Separation of, all right, chemicals or substances, all right, substances in a mixture. So I'll be much of talking than writing, all right, because of the time. We don't have time. All right. So that is about the that's about chromatography. Then the other thing that we need to talk about, you can also define it, separation of complex chemical substances. Okay. All right. So complex substances, you can also define it like that. So this chromatograph, most we could do it at secondary level where we involve something like a paper. There we'll put a paper, and this paper has, let's say, a pencil like that, a pencil line like that. So we could dip in something in a mixture like that, then the solute will move now across this. Some will reach here, some will reach there, some will reach there. The distance traveled by these substances will actually show the separation that they are not together in this. So there are other reagents that we use inside there, like to put so that the solute can move there. We'll talk about them, those. All right. So that's about chromatograph. This is what you call paper chromatography, where we could dip the paper inside there and have some what we call the separation as indicated of dyes, colors, paint, inks, like that. We remember doing this. Now that this technology we have, things have changed now. All right. So now what is happening is that there's what we call now, suppose this is a chromatograph column. They are what we call columns. All right. So it's now the column now are being coated with something like powder, gas, or most is powder that we coat around this. This is spherical. So we coat something inside there. So upon us coating something inside there, around this wall, we coat some chemical substance called a stationary phase. So what is coated is what we call stationary phase. Okay, it's not moving, that's why it's stationary phase. Then we can do the upward injection, or the downward injection or the upward injection, depending with the type of chromatograph and how effective and also the type of solution we have. So also that matters. All right. So this means that what we have is that thing that will dip, like we inject, okay, as solute, just a reagent to say, it is what we call a mobile phase, because it will move through the mobile phase. Mobile, something which is mobile is something that is moving. Okay, so this is what we call a mobile phase. All right, so this is a mobile phase, and this is a chromatograph column. All right, chromatograph column. All right, so that is it. So these are the things that we'll be finding under chromatography. Okay, so I've introduced now to that. So first of all, let me define that. So I said the first thing that we can see is the mobile phase. Okay, mobile phase. Okay, so that mobile phase is just a solvent that flows through the supporting medium. The supporting medium is what? Is the column that we said. All right. All right, so that's what we call a mobile phase. That move through a supporting, the supporting column is there, this column, I mean the column. All right, so a mobile phase is just a solvent that we inject there and move such that different dyes are separated like that, okay, such that with their distance we can even quantify them because of the distance numbers that we can see there. So that's what we call a mobile phase. Then the second term that you need to be familiar is what we call, the same thing I explained, is the stationary phase. So what is this stationary phase? All right. So stationary phase is just a layer coating that we put around there, around this, so that as this one we inject this, because this thing is very small. As we inject this substance, the molecules are able to be attracted to the stationary phase, depending with the interaction that will be there, whether they can match or not, so that the separation can be achieved. So what is inside there, the small thing that we're able to see inside there, is what we call the coating, I mean the coating thing on the supporting medium, which is the stationary phase. So a stationary phase is a layer or just a coating on the supporting medium. Hope that makes it clear. So this is just a layer on the supporting medium. Then let's talk about the same supporting medium itself. All right. Okay, what is this supporting medium? So if you want, you can come up with your own notes according to what I'm just explaining. I'm much of explaining than writing because it wastes our time. So that is it. A supporting medium is just a solid surface. This surface we have there, on which I can say on which the stationary phase is coated to or bounded to. All right. So this is just a supporting medium. Okay. What's this? Supporting medium, which is just a column or a solid surface on which the stationary phase is coated to or bounded to. All right. So a supporting medium is a medium on which the stationary phase is bounded to or coated to on. All right. So that's what we call a supporting medium. So basic term that we can also find are so as these things, these like we inject a molecule, I mean the solvent, we inject a solvent in this. I'll demonstrate, I think as days goes, we'll be able to show you the the analytical column, which is the chromatography column. So I'll demonstrate it. I'm sure I'll have chance to demonstrate that in other segments of this lecture. So what we are trying to say is that the basic term that we will be finding here is the first term that we find is adsorption. So in as much as the molecules are moving inside there, they can actually stick to this wall. So that let me say adsorption. So that ability of the molecules or the particles in this solvent, as we inject the solvent, it will go up or down. So depending with the type of setup we have. So the molecules will be sticking also to this surface of the column. So and that's what we call adsorption. Adsorption is just the ability or the interaction of solute molecules with the surface of the stationary phase. So that surface of the stationary phase. So this is just interaction interaction of this is just the interaction of um, um, molecule or solute. The solute are the one moving solute with, so the interaction of molecule, I mean solute with stationary phase, because stationary phase is the one actually that actually possess the movement, also slower or make it faster. Okay, stationary phase like that. So that's what we call adsorption. Then the other terminology that you need to be familiar with is what we call eluent. To eluate is something like to move. All right. So eluent is something that moves. And what is this moving is what we call a mobile phase. A mobile phase is actually a phase that moves inside. So it's more like a solvent containing solute inside there. Okay, that's what we call a mobile phase. So it's a solvent containing solute. So eluent is the mobile phase. Eluent, then the process of eluating is what we call um, the process of eluating is what we call now eluation. Okay. So elution, like, let me call it elution. All right. So elution, all right. What is this elution? Elution is just like the motion of the mobile phase, like I said. So this is just the motion of the mobile phase. All right. Okay, so that is what we call a motion. I mean, erosion. So this mobile possessed by the mobile phase, which is the eluent, is what we call erosion. So I think I'm making it clear. So as the solvent that is we inject where it has a solute inside, as it move inside there, the solute will interact different with the stationary phase coated on the medium. Then that motion that is being done is what we call the erosion. So the other term that I can give you is again is what we call erosion time. All right. I think this is now becoming very clear. Erosion time. All right. So what is this erosion time? So erosion time is actually um this will be a time taken for solute to pass through the system. So as the solute move up down there, all right, that time taken to pass through this system, where suppose the coating starts from here and ends there. Okay, that time taken between that part distance is what we call erosion time. All right. So time taken for a solute, for solute, for solute to pass through the system. Let me say the system, or to pass through the system. That is what we call erosion time. So time taken for a solute, those solute that will be moving to pass through the system is what we call erosion time. Okay. Hope I'm making it clear. All right. So the other thing that I need to talk about is all right. Okay, the other thing that we need to talk about is, but you need to know that as solute with the short erosion time travel fast, because um, it's more like those ones with the short I mean, like those ones which travel like fast, they have short erosion time, because the time which will be taken is like, let's say it's 2 minutes, then other solids they take 5 minutes. So these ones, they have erosion time or short erosion time. All right, so that's what you need to understand there. All right, so let's talk about now stationary phase in details. Okay, let me talk about stationary phase in detail, because it's the one actually having our study. So stationary phase, we said, is the part of chromatograph that is fixed in place, like in a separating or in a analytical column, like that chromatography column. So that thing that is coated in that, it is stationary, it is coated already, bounded. It can be of powder, but we bound it around this medium, okay, which is supporting medium. Then the solid, this thing is very small, by the way. These particles, they move due to what we call uh, by capillary actions. The capillary action is just a moving of solid from high concentration to the low concentration. Like the case of, we put paraffin, let's say, on a cloth, it will move like that, because of tiny holes that are in that cloth. So it will make actually reach even the other part of the cloth that you are not even, where you are not even expecting. That's what we call capillary action. Okay, so they move via capillary action. So take note of that. So that's what actually happens in the mobile stationary phase. Particles will be moving. What makes them move is because of capillary action. The stationary phase has thin holes where these things from the solvent can penetrate in it and make it possible to reach the highest point so that they can separate. Those one with a high erosion time, they'll move faster there and reach the destination if possible. So that's what I'm trying to say. So what you need to know is that more attraction to the stationary. So if particles are attracting themselves to the stationary phase, this means that um, the particles will move slowly. All right, slowly. So get my explanation. Then, as more attraction to the mobile phase again, they move fast. Okay, move fast of mobile phase. Okay, so like slowly of stationary phase because they won't move, they won't be taken. And the other thing that we can do for us to make them fast, I think applying temperature will make them move fast. Anyway, that is another segment. So what I'm trying to say is as they move slowly, it means they are sticking to the stationary phase, which is actually, suppose the moment you just inject them here, they will stick to this and they won't move further to up, I mean upward there. So those are the things that we need to. So as they stick to the stationary phase, um, they cause actually um, what we call they will be slow in motion and like won't detect them at that point. Like they will remain and you consider them to be of just heavy solute. All right, so that is it. Um, then those things that we are actually investigating are what we call anarate. Okay. Then in this distance, let's suppose this is 20, this is 10. Okay. Is what we call retention factor. So retention factor is the distance traveled by the um, traveled by the particle, let's say um, distance traveled by the that solute over the total distance of that column. All right. So you find that the total distance of the column or the stationary phase distance is, let's say for A it moved, let's say 10 meters, then the column had, let's say 20 meters, so this will be 0.5. So this means that this is the ratio of we can actually detect some quantitative information based on these number calculations of retention factors. So let's talk about uses of chromatography, then from there we'll talk about something else next. All right. So say uses of chromatography. So what are the uses of chromatography? One, we can use this to separate mixtures. So separate mixtures. So you can light this. Then the other thing that I can actually come up with is to identify. You identify compound based on that. You say, okay, the compound with reference, suppose you have reference materials. So you say, whenever you see, let's say 915.5 distance traveled, then you can tell that this is, let's say, a carbonyl compound, whatever case. So we can also identify identifying it dealing with quantitative. Identify compounds. So the other thing that we can do is to check the purities. We check in a calibration, like we check whether this purity you have, we are, let's say, claiming to say this is ethanol. Then we take, we know ethanol will travel 15 meters, and we take yours is traveling 15, let's say 14 or 15.6. It means that is not pure. Okay, pure will actually maintain the same reference information that we have. So that's what we call when you check purity. Then the last one I can say is to quantify. We quantify based on these numbers. Okay, quantify substances. So these are the uses of chromatography in general. We still have a lot as we'll be talking about different type of chromatography. So stay tuned and make sure that you don't miss any of the segment. This will help you. Thank you very much. Remember, separation of identify compound, check purity to quantify substance. This actually marks the end. Thank you very much. That was just the intro part of chromatography. Wishing you the best.